Hello, and a very warm welcome to Cognito Key. Today, we're going to pull back the curtain on a piece of technology that's, well, it's everywhere. It's running silently, powerfully, and most of the time, we don't even know it's there.
All right, let's just jump right in with a fun little question for you. Think about your kitchen blender. And now, think about a super high-speed train. I mean, what on earth could those two possibly have in common?
You guessed it, it's the electric motor. Yep, that's the hidden hero in both of them. It's this unseen power that literally makes our modern world spin, blend, and move. So today, we're going to figure out how this incredible invention actually works.
Okay, so first things first, what exactly is an electric motor?
Well, to put it simply, it's a machine that takes electrical energy, that invisible power flowing through the wires, and turns it into actual physical movement. It's basically the magic trick that turns electricity into a spinning shaft or a turning wheel.
So how does it do that? Well, it's all about this really cool dance between magnetism and electricity. See, when you run an electric current through a wire that's sitting inside a magnetic field, it creates a force, a little push. And that simple push is what we harness to create rotation. It's such an elegant and powerful idea, right?
Now, to really get a handle on motors, you've got to know they basically come in two main families. Think of it like the first big fork in the road. You've got your AC motors and you've got your DC motors.
And it all comes down to the kind of electricity they use. AC, that's alternating current, is the power you get from the plugs in your wall. DC, or direct current, is that smooth, steady power you get from something like a battery. And believe me, this one little difference creates two totally different worlds of motors.
So let's start with the motors that run pretty much our entire homes and all our industries, the AC motor family. These are the real workhorses plugged into our power grid.
And inside that family, the undisputed king has to be the induction motor. Seriously, if you have an appliance with a motor in your house, the chances are incredibly high that it's one of these.
So a key thing to know about them is that they're asynchronous. Now, that just means its speed isn't perfectly locked to the electrical current. There's a tiny bit of slip, and that slip is actually the secret sauce that makes the motor work, using a really clever principle called electromagnetic induction. And the most common type? It's called the squirrel cage motor. And yeah, it's named that because the inside part literally looks like a hamster wheel. It's loved because it's just so simple, tough, and super reliable.
And this is where you really see how common they are. That low hum from your refrigerator, the whirring of a fan, the churning of your washing machine. Yep, that's the sound of an AC induction motor hard at work.
Okay, now for the other big AC motor, which is a total specialist, the synchronous motor. And as the name kind of gives away, this one is all about perfect timing.
So unlike its asynchronous cousin, this motor's speed is perfectly locked, or synchronized, with the frequency of the power it's getting. This makes it absolutely perfect for anything where you need a precise, constant speed. Think old-school clocks, timers, or even high-end record players.
All right, let's switch gears and cross over to the other side of the family, the world of DC motors. These are the motors that give us portability and fine control, all powered by things like batteries. The core idea here is really direct. You take a wire, you run a direct current through it, and you put it in a magnetic field. What happens? It feels a push, a force. And by cleverly arranging these wires into a coil, we can turn that one simple push into nonstop continuous rotation.
So most DC motors are what we call self-excited. This just means they create their own magnetic field using some internal coils. And how you connect those coils to the spinning part of the motor, well, that completely changes how the motor behaves. And this gives us our two main types, the series motor and the shunt motor.
And as you can see, it's really all in the wiring. In a series motor, everything's connected in one big loop. But in a shunt motor, the field winding is in a parallel branch. Now that might sound like a small change, but it has a huge impact. Series motors give you incredible power right from the start. That's why they're in power tools. Shunt motors, on the other hand, give you a much more constant speed, which is great for things like fans or conveyor belts.
Whew, okay, we've covered a lot of ground pretty fast, so let's just zoom out for a second and recap the key takeaways from all of this.
So, what's the big picture here? Well, first, motors are the magic link that turns electricity into motion. Second, they fall into two main camps, AC for the power from your wall and DC for power from batteries. AC motors, like the induction motor, are the tough workhorses powering our homes, and DC motors are the heroes of portability and variable speed. But together, they are the unseen, quiet power that drives almost everything.
And that brings me to a final thought for you. Right now, wherever you are, just pause for a second and look around. The fan in your computer, maybe a clock on the wall, the little buzz when your phone vibrates. How many of these tiny, invisible motors are working for you at this very moment? It's kind of amazing when you think about it.
I really hope this quick tour has shed some light on the incredible world of electric motors. Thank you so much for joining us here on Cognito Key.
If you found this interesting, please do us a huge favor and hit that like button. Share it with a friend who might be curious, and of course, subscribe to our channel so you don't miss our next explainer. We'll see you in the next one.